Now, if you're going to be writing up some programs, you're going to need to know how to do it right. Successful programmers and coders rely on philosophy of developing programs in a consistent manner using recognized techniques and methods to create organized and efficient code to meet the software specifications. There's 3 parts to this. 1, sequence. 2, loop iteration. And 3, selection decision. Okay, now sequence. Sequence, like coding programs that execute in order or sequence from the first instruction all the way to the last line of it. What it is, you use this to have well-organized code that runs in a logical order. The program flow is easy to follow. What it ain't, code that intermingles one task with another, jumps hither and yonder, and you can't tell what's going on. Loop iteration. It's defined as using the for loops, do loops, while loops, statements to choose a response or action to be executed. What it is, you use a loop or iteration results in more efficient, better structured code. Consequently, the program will need fewer lines of instruction, i.e. easier to write. What it ain't, code that has the exact same set of instructions over and over and over again. Selection decision. It is using the if-then-else statement to choose a response or action to be executed. Also includes this thing called switch that you can't do in Scratch. What is, when a program has to decide which way it's going to go, use true, false, that's that Boolean stuff, and or XORs and nots. What it isn't is when you keep using if then, if then, if then, if then, instead of putting them together in like if then else's. Structured programming action. Let's watch these examples from our simple Scratch programs, and it'll give you an idea of what you should be doing. Here's our first one, sequence. First example has good sequence. We put Scratchy at 0, 0. Everything's positioned. It goes straight in order. Ask you your name and stuff. And you play the game down here. And when you're done, ask if you don't want to play. And then it exits all nice and cleanly. What sequencing is not. This example shows you all the same code, but it's not in the same order. The sprite doesn't get positioned till the end. Ask what your name is at the end. Shows you how amazing it is at the top instead of in the middle, and it's just not in order. Sequence has everything going in order. Loop and iteration. Here's a good example of what a loop and iteration doesn't look like. Sometimes a bad example is just easier to follow. In this code we see change, move, say, change, move, say, change, move, say, change, move, say. Now you might need to do that 4 times, but if you use a loop, it'll make much more sense, it'll be more efficient, and even a newbie stumbling around the palette will eventually come to the idea of like, whoa, what's this loop thing? Maybe I should use it. Here's a better example. Notice we have the same action going on, but we've put these things inside of a repeat loop. Repeats 4 times, and what we've done here is we have cut the number of instructions that program in half, does the exact same thing. If you ever find yourself doing the same thing, entering the same commands, time to hunt for a loop, bubba. Selection decision. In this code, the users ask for their favorite colors. And if they say purple, then they get one response. If they don't pick purple, then they get another response. In this case, a selection decision is necessary, but it hasn't been implemented to its best effect. Here we have the same effective program, but it asks if favorite color is purple. If you say purple, yeah, man, that's my favorite. And if they don't, they say, oh, that's not my favorite, but it's in an if-then-else. Far more efficient, and less steps in your computer coding. It's easier to follow. Now, word about readability. You got a program, if you have stuff all scattered over the place, you can't figure it out. If computer programs were only designed by a single programmer, never had to be debugged, never had to be checked by anybody else, never had to be modified once you finished it, never had to update it, and the programmer could remember exactly why it did everything 2 years later, well, program readability wouldn't matter, comments wouldn't matter. However, in the real world, programming is a team sport. You have groups of people working on something together, sometimes at different times. Sometimes a guy get called off that project and go to something else, and the new girl coming in looks at it and says, man, I can't follow this. What's this doing? So you need to document everything real well because programs do have to be updated. There's new technology that comes out that people want to use. Customers say, hey, can you make it do this now? Well, if you don't have documentation, you can't figure out how it works in order to update it. And so think about readability and having lots of good comments on your code there. So Make sound code using structured programming. Put these concepts into practice with each program code you make, and your programs will be more effective, more efficient, less work, and easier to debug. Thanks for watching my video, guys. Catch you later. Bye.